Good morning, everyone. Again, we are going to continue with the principal component analysis R codings. So today we are going to discuss another R code for principal component analysis. Here we are going to prepare a code that is basically complete PCA principal component analysis workflow as a function. We are going to define it as that one. So here we are going to define a function that we are going to store in the command PCA analysis underscore analysis. We are going to define it as a function of data. All right. And we are going to say scale equals to true. After that, we define the function. If we just go for the pre-processing, where we will clean the data that we remove all the NA.omits in the data set, whatever the data we will provide in the end. So we will remove all the NAs from the data set, and in the second part we will apply the PCA through the command PRComp. All right, and we use the clean data set and we apply the center equals to true, and scale dot equals to scale means we are going to provide the scale equals to true here. All right, and then we just go for the summary of the statistics. We find out the variance. Okay, means we will find out the PCA dollar standard deviation square divided by sum of the PCA divided dollar sign standard deviation square, means we are going to find out the variance explanation. All right, total of one particular principal component divided by the overall total variance, and then we just find out the cumulative sum of the variance by the command sum and variance underscore explanation, and choose the component. We are going to put the rule of 80%, means if the variance cumulative sum of the explained variance is greater than or equals to 0.8, we will select those principal components. So that will be stored in n underscore comp equals to which cumulative sum of the variance is greater than or equals to 0.8. We will select that one. All right. After that, we are going to extract all the results by storing them in the list PCA equals to PCA, where in the PCA we apply the principal component and n components. Basically, the n comp we are going to apply here, which components are having the cumulative sum equals to or more than or equals to 0.8, and cumulative variance we are going to store in the cumulative underscore variance, and loadings we are going to store in the loadings, that is we are going to call from the PCA dollar sign rotation. The rotation command is basically we use to call the loadings. All right, that will be the columns of all principal component and scores we are going to store in the PCA dollar sign X of all component vectors here. Okay, from the all n components, and then we use the results. We will call the results here PCA analysis. We are applying on the empty cars, and we are going to select the first 7 columns of the data set. Okay, we will check which are these 7 columns first, and then we will run entire code. Okay, these are our 7 columns: MPG and cylinders and others. All right. So in that one, this data set is basically extracted from the 1974 Motor Trades US magazine, and it contains the fuel consumption and automobile design data. So total there are 32 cars in this data set we have, and total number of variables are 11 features. So they examined the 11 features, but we are selecting only 7. All right. So first is the MPG, that is miles per gallon is given. Second one is the engine. Related to the engine, basically the cylinder, number of cylinders, how many cylinders are there, 6, 4, 8, whatever is there. Third is basically disc, that is the displacement, means unit the cubic inches, okay, measure the engine volume basically. And fourth one is the HP, that is the horsepower, okay, so it measures the engine's output power. And fifth is the DRAT, basically the rear Alex ratio, so that is basically mechanical ratio affecting acceleration or fuel efficiency. And then we have the weight, okay, weight of the car's actual weight, that is basically in the pounds, 1,000 pounds, and that one. And seventh is the QSAC, that is the quarter mile time, basically the time to travel 1/4 mile that it is going to take, okay, basically in the seconds. So that is the data set that we consider here. And now we are going to run our entire R code that we prepare. So that is, now we will call the results. Okay, this is our two principal components. Okay, and this is our entire results, the standard deviation of all covariates and rotations with respect to all principal components. Okay, all 7 principal components, and then we will check the variance that they are going to explain. So first is going to explain 0.72, second is going to share 0.16, another is going to share 0.492, and so on, and others. So if we just see here, first two components are sharing 0.89 or 89% of the 89.18% of the total variance. So we are going to assume only or consider first two principal components. Okay, so these are the loadings of first two principal components, and this is the score of two principal components. So that's how you can write your own principal component analysis R code by your own, okay, in the form of function. Thank you.